Hello everyone, thank you for taking the time to watch. My name is Rami. I will be presenting to you the work I conducted for my 4901 directed special study with the Dynamic Behaviour Lab. Supervised by Dr. Roz Dakin, Ph.D. candidate Illias Berberi, we took a look at an analysis of the adapted strategies we used to measure miniature wing bones in hummingbirds and manakins. The objective of the study overall pertained to the ecological question of how morphological variance in these traits influences flight behavior and the networks of these bird populations. My role focused on developing upon the strategies and the protocols we use to mitigate the error rates associated with fine-tuned measurements of miniature wing bones. Skeletal images were photographed by my colleagues at the Louisiana State University Museum of Natural Science, for which we used ImageJ to transect the lengths of each specimen's humeri and radii digitally. Observations for hummingbirds were made by different observers, while the manakins had their dataset randomly reordered and remeasured by the same observer. We then leveraged the R-Library tidyverse to draw comparative analyses on observer accuracy and of average dimension in each trait as support for the protocols we used. As can be interpreted by these first two figures, manakin radius to humerus proportions were reproducible to the same observer, with the same dataset being the collection of images randomly reordered. Taking a look at these next two figures on manakin humeri and radii pair averages between trials again shows high consistency in the results, showing that the protocol yields reproducibility. In the top left, we have an example of a transect on the radius from the styloid process to the head, and similarly on the right side with the humerus going from the trochlear indentation near the bottom there to the apex of the head. The determination coefficient for the hummingbird dataset was a little weaker, although remarkably, it still held accuracy in the face of two observer measurements, radial on the left and humeri on the right, very similar to what we expect on the null slope, showing that the same accurate morphological data can be reproduced independently, justifying the employment of this protocol in and outside the Dynamic Behaviour Lab in future studies on the role of morphological asymmetry in behavior. I recommend future generations of the Dynamic Behaviour Lab study higher dimensional geometries such as surface area, volume, and different orientations of these bones by identifying key landmark features and traits on bones as depicted by figure R2, as well as refining qualitative data into concise, standardized parameters such as gunky, obstructed, missing, or broken, to compare how different categories might retain their sensitivity to these protocols. In addition, contextual data on environment and cause of death as fitness determinants can also serve the same purpose. To incorporate potential applications such as regulatory mechanisms by evaluation of the vulnerability of these birds to anthropogenic infrastructures and how to mitigate these threats based on a population's morphological distribution. And finally, incorporating artificial intelligence for high throughput, leveraging landmarks, qualitative data, and contextual data. And finally, I'd like to just denote that this experience was expansive to my knowledge and skill set. I wish the future generations of this lab an equally enthralling mission to accomplish any of these strives for high throughput, robust morphological analyses from the context of wing loading and beyond.